Hello, everyone, and welcome to today's webinar. Today's webinar, we will be talking about some of the new options that we have in 2.5D milling, as well as some things in turning and some other nice surprises that we have in store for you. Actually, something that we call SolidCAM ShopFloor Editor and simulation. But before I start the webinar, Emil would like to say a few words. So, Emil, go ahead.
Hello, everybody. Nice to meet you again in one of our webinars. I really appreciate those people who follow up our webinars to get the latest information, technical, also sales and marketing wise. Sidney mentioned two new products that we are showing today. Actually, one of them has been available for already a couple of years, but we didn't do much marketing about it, so very few people knew about it and got it. This product is called ShopFloor Editor. It enables the machine operator to open existing CAM parts, edit them if needed, simulate them, including machine simulation, and regenerate the G-code for the CNC machine. The ShopFloor Editor is designed to be used on the shop floor to enable editing of programs created by the SolidCAM programmers. The editor gives shop floor people full control for editing programs like change the step down or change the tool speeds and feeds. Again, recalculate the operation, check the simulation, and generate a new G-code, right by the CNC machine or somewhere close by. In what scenarios you would need to use the ShopFloor Editor? Let's say the machine operator is working in a different shift from the CAM programmer, and the CAM programmer is not available to make any changes, so the machining operator can make minor changes and regenerate the G-code. Or maybe the CAM programmer is relatively new to machining and has less experience than the machine operator. Then the ShopFloor Editor gives the shop floor personnel the flexibility to make minor changes more suited to a specific application and CNC machine. In the ShopFloor Editor, all CAM functions are available for editing: milling, turning, mill turn, eye machining, standard simulation, machine simulation, and post-processing. Now, the second product is called the ShopFloor Simulator. The difference from the editor is that it cannot do any editing, but it can provide the machinist with a full simulation of the CAM part. He can see the tool table list with full details, understand the clamping, the home position, and to see the entire machining picture, including machine simulation, before running the G-code on the CNC machine. No changes whatsoever are allowed to the CAM part. Both products will be available in SolidCAM 2021 SP1 to be released shortly. And also, we are creating a hotfix for SolidCAM 2020 SP4 hotfix 1 to include both products. Both the ShopFloor Editor and ShopFloor Simulator can be run either standalone or integrated inside SolidWorks. So enjoy the webinar. Sidney, go ahead.
Okay, thank you very much, Emil. And let's get started. And we will start. Here we go. First, let's start with some of the options that we have. One of the options that we improved inside our face milling. In face milling, you can now do what we call a roll-in approach when using hatch. This is the roll-in approach is actually what is most recommended when going into the material by the manufacturers. Let's see for a moment exactly how this works. And I will bring up my program. And if I would open up my operation that I have over here, and you can see that if I go into my technology, I am working right now in hatch. Okay, if I go into the hatch, we've added the option over here called approach roll in. where it actually rolls into the material instead of going straight on in. This is a lot easier on the tool itself, especially when you're talking about inserts. And this is, as I said before, is most recommended when working with inserts by the manufacturers themselves. If we take a quick look at the simulation itself, and I run my simulation, you'll see the following. Let me put this actually on the top view, and I'll do this one step at a time. You'll see the tool actually rolls. Well, I went a little quick over there, and I'll actually show my toolpath. I'm not showing my toolpath, so let me show the toolpath itself. You can see that the tool's actually rolling in. You can see the actual roll in motion as it's going across the part. When it comes out, it does the same thing. Next step also rolls in until it finishes the part. So this was an improvement that we've done inside face milling for hatch, allowing you to roll into the tool path. Okay, now let me go into my next little change that we have over here. Excuse me. Okay. In a profile operation, when we work with a center tool path, we've now given you an option of flipping the direction for your lead in and lead out. And let me just the best way to explain this to you is actually to show you exactly what we're doing actually over here. Okay. Excuse me. If I were to open up my operation, let me just take a look over here what I want to do. I'm just giving you a specific scenario. You can see I have a geometry over here in this area on this edge. You can see that actually very clearly over there. Now, what I'd like to do is I'd like to have the end mill possibly go over the center of it. Maybe there was a burr that was picked up, but I don't want to put a chamfer in, so I just want to break the burr. And I just want to keep it as a sharp edge, but I want to have my end mill just go over the center of that edge. Okay, I'm sure there are many scenarios that you can think of, but that's one that I just wanted to bring out exactly to show exactly what's going on over here. Okay, so if I go to my technology, you'll note that I'm working center. Okay, my link, I'm using an arc link, and if I were to run my simulation exactly the way it is right now, I'll do this one step at a time. You'll see that my tool is actually going in over here, and that's not necessarily what I wanted to do. I would prefer it actually going on the outside of the part, coming in from the outside and rolling in. Because as you can see, in this particular case, I may damage the part, which I just did. So now we give you the control to be able to flip the direction, both for the lead in and for the lead out. Save and calculate. You can see already over here on the toolpath that the direction has changed. Running my simulation, you can see again that the tool now will go down. And this time, it stays away from that wall instead of actually hitting that wall by turning into it. So now you have complete control as far as your flip direction with the center toolpath. Okay, now let's get into something a little more juicy. Over the years, we've had thread mill, and the thread mill operation inside milling, but it was very, what would you call, very plain. Okay, there was very few options in it. You had basically, you can choose the type of thread you needed, the standard that you needed, how deep you wanted to go, but you had absolutely no control of your lead-ins and lead-outs. You had no way of dealing with multi-starts. And when you did rough cutting, there was very little you can do. You just hold it, step in, and every single time is stepped in at each time. Let's go over each step at a time and show some of the new options that we have here. And the first one, as you can see on my screen, we're talking about multi-starts for thread support. Now, many of us know that a lot of times, not all threads are just one single lead. Sometimes you have a double lead, triple lead, quad leads. In other words, you can have more than one lead for the thread itself. So now we give you complete control for the amount of starts that you want on the thread itself. Let's take a look exactly how this works in the program itself. And for that, I'm going to load a different part. And just a moment. Okay. I've already created the operation to make it go a lot smoother. But in this particular case, if we take a look at the top view over here, sorry, that's not what I wanted to do. Let me reclose that. If I want to take the top view of the part, you can see this particular thread has two starts, one over here and one over here. Okay. Now, I'm going to go into the operation itself. And you can see the tool in this particular case has a 2mm pitch to it. But if I go into my technology and I'll go into my advanced, okay, you'll note we have the option over here of number of starts. Now, you noted I didn't mention before that the pitch was 2mm, but because we have two starts, you'll note that it automatically has a thread lead as 4, because now there's 4mm in between each thread on each specific start, in order to get two threads in there to make it a 2mm thread. So in this particular case, number of starts, 2. Okay, let's run the simulation on this. And I've been running lately the new simulation that we have in SolidCAM. And what I'm going to do, I'm going to zoom into the part itself. And I'll do this one step at a time. You can see that goes down. You can see now it goes down to its next step over there. Until it gets to the bottom. Now you'll note, since it's doing a rough cut, it's finishing that particular thread. And I'll talk about that in a moment also. But you see it's doing that one thread. And then when we finish that thread, a moment, okay. Let me actually run this direct a little slower though. When it gets to the end, which it should be in just about a moment. There we go. Now what you see, it's actually now working on the second thread, which is right just in between over there. In other words, you're getting the exact type of thread that you need. You're getting the thread with two separate leads. These are usually used in areas where you need a quick release or a quick lockdown. So that's why these types of threads are used. There are many reasons why you want to use these type of threads, depending on the engineer that designed the part. Now you'll notice that by the way, that it went down, it completed each particular thread before it went down until it went over to the next thread. This can be controlled over here. I can either sort complete thread, which is what I did just now. I had to complete the thread, or first I want to complete each step over. If I were to do that and then run my simulation, again, I'll zoom in over here. You'll note this time it's going to do that one thread and then finish that level, that particular depth, and then go over to the next thread. No, it's going 1 and 1. So you have complete control of whether you want to have a complete step over or complete the thread itself. Okay, next. In thread milling now, previously, when you did a rough cut on your thread mill, you were not able to control any kind of rough pattern. It always went in through the middle till the end. There are many people that like to work only on one side of the thread, whether it would be going from the top towards the middle, or from the bottom towards the middle, or even a zigzag pattern. So now we support this, and we have this just like we have in our turning operations where we've had this. We have this now in milling as well. Let's take a look at this. I'm going to open up, this particular operation over here again. Sorry, my mistake, not that one. This one, okay. Open up the operation, and you can see over here we have the rough patterns. Now, right now, it's going in directly in the middle. If we were to take a look at the simulation, okay, and I'll put it in this view over here. Now zoom in. Now, I'm going to do this one step at a time. On purpose, I'm not going all the way down to the bottom so that we can see this a lot easier. Now it's, whoops, sorry, my mistake. Start from the beginning again. There we go. That's what's so nice about this new simulation, by the way. I can always easily go back and you see exactly what I missed. Okay, so let's do one step at a time. Actually, the best thing is I just redo it over here, go back into the simulation, zoom in. There we go. You can see the first step, and I'm actually going to zoom in really, really close. Okay. Now you can see the first step actually going dead center over here. Okay. You'll also see that the next step, let me stop it on the next one as it gets down there. You can see the next step is taking off. Here's where the cutter is itself. It's taking off on both sides of the thread, going dead center. In other words, continuing exactly the way it used to work previously. Okay, so we have that option as well, as usual. Now, let's take a look what happens if I change this. I want to have this now, instead of going straight on the middle, I want to go from the top towards the middle. So I'll click on that, save and calculate. And let's take a look now at the simulation again. Okay, this time I use the regular simulation. Actually, you know what? Let me go back and do the SolidCAM simulation. I happen to like that. By the way, if anyone wants to know how I get directly, if you don't know yet, how I get directly to the SolidCAM simulation from here, if I hold my control key and then click on that, it brings me to the SolidCAM simulation. Okay, so let's get back to what I was saying. I'll zoom in over here. This time, here we go. You can see it's actually starting out from the top, going down. Finishes the thread. Then the next time it goes down, it goes further down from the top. In other words, it's always working from the top down in this particular case until it gets down to the actual depth of that particular thread. Always working from the top down, always having, and let me stop this for a moment. The pressure of cutting is always on this edge over here. in this particular case. Okay, now we have the same, just the opposite. Clicking 3, we started from the bottom going up. Save and calculate, and again, run my simulation. This time, again, zooming in because it's the best way to see it. You can see now it's starting from the bottom and working its way up instead. And we can finish that off, speed it up a little if I want. Okay. Now, the next option is actually working zigzag, where it goes pressure on one side, then pressure on the other side. In other words, it goes back and forth between the steps. In other words, it stays always towards the middle, but a little bit off to one side and then a little bit off to the other side. Let's take a look exactly how this works also. Again, I'm running my simulation. Zoom in, and you can see the first step looks almost exactly dead on center, which it is, by the way, in this particular case. Okay, dead center. And now on its next step, and I want to stop here, you'll note that this area is not cutting this time. This is what's cutting. Okay. Now the next time, you'll see it'll be just the opposite. This time it cut from the top. Though it's going back and forth. Here you go again. Cutting from the top, and then the next time from the bottom. So we have complete control of our patterns over here. Okay. Now, one other thing inside our thread mill is we also now control the lead in and the lead out. And you can now, when using on external threads, you can do it with an arc, normal, or and tangent. Okay, so you have complete control exactly how you want to lead into the part. Something that we didn't allow before, but we do that now. Obviously, if you talking in as in a internal thread, what we do allow is arc and normal. Obviously, tangent you can't do it because then you ruin your thread. Okay, let's take a look exactly what we're doing over here. I'll reload a different one over here. I'm going to roll this particular lead in this particular operation over here. And if we take a look at our links, you can see in this particular case, just to show you both of them, I did a lead in with a tangent. I specifically did it with a large value over here, just so you can see it a lot easier. And in the lead out, I actually made lead out by arc. Okay, let's take a look at the simulation. This time I'm going to use a regular. I'm going to use a regular simulation itself. And we'll take a look at the top view, one step at a time. You can see that the tool now went in a tangent motion towards the thread. As it works its way around, let this actually go all the way to the end. You can see that the lead out is with an arc. Lead in, tangent, lead out with an arc. Something that people have been waiting for quite a while to give you the complete control of how you want to do it. Now you have it. Okay. One more bit of information that should be known also is that your thread data, you now have able to control the minor diameter. In other words, if you have a different minor diameter that's slightly different from the standard, you can actually put in your minor diameter. So this way you can reduce the error cutting passes. you can control exactly what your minor diameter is, and not according to what was automatically given to you before. Okay. Now, one other thing, and this is important also. We've actually made the your rough control, your rough step-ins, a lot more efficient. And this also works exactly the same way that it's always worked in our turning operations. What it does is as follows. When it steps in, our first step in always controls a certain amount, takes out off a certain amount of area on the material itself. Your next step in will be less as far as the step in goes, but will cover the same amount of area. This one will also be less than that one and less than the one before, but the amount of material that's being taken off each time is the exact. You can see that S1 equals S2 equals S3 equals S4. In other words, the amount of material being actually taken off is equal each time. And in the program itself, you'll see that you have your first step over and then your minimal step over. What's the minimum, the amount that you're willing to take off each time? Okay. And of course, your finish allowance, which is the amount that you want to leave for your finish cut. Let's take a look exactly how this is. I'll go back into this particular operation over here. And if I go back into my technology and advanced, sorry, not in advanced, in our technology, you can see that we have our rough, we have our multiple cuts, we have here our first steps, and then the minimal step. In other words, they'll go down from 0.2. It'll calculate the amount that has to actually go in, but it'll never go less than what I put down over here. Let's take a quick look at this also, so I can try and point this out. And we'll put this in the side view this time. You'll see at the first step, now try and point this out. This is the area that it's taking off material, okay? Now, when it gets to the next step in, you'll see now, and actually zoom in a little more, this is the amount that's actually being taken off now. Oh, sorry. This, in this particular case, is going zigzag still, but this amount of material is the exact same amount of material that was on the first step as it went in. And this will be the same thing as it goes through the part. It gets less and less until it does its minimum step in. Okay. Next. In our thread mill also, just for your information, depth definition, if you have number of threads, you can now also give it as a decimal point. You always, before you had to give a whole number of the amount of threads, but now you can give whatever amount of threads you want, 15.25, 15.5, giving you complete control of the amount of threads that you want on a part. Okay, now let's get to something that people have been waiting for a long time. A couple of years ago, we introduced drag and drop templates, but this was always used for milling operations. We can now use drag and drop templates when it comes to turning as well. Let's take a look, and as I'm showing it to you also, I'll explain some of the features that you should pay attention to as you're doing this. Okay, so let me open up a different part. Okay. Now, in this particular part, this happens to be a mill turn part. But let me just go into my coordinate system manager before I continue. You'll note that I have two mech positions, 1 and 2 on the other side. Right now, all I want to do is work on this side. Now, we know that with drag and drop, if I have more than one home and both homes are able to be used for that same geometry, it'll keep on asking me which one I want to use. So in this particular case, always a good idea, if I go into my coordinate system over here, instead of putting on automatic, I can always choose my coordinate system, and I want to keep it permanently on 1. So I don't have to keep it, doesn't have to ask me every single time which coordinate system I want to work in. Now, let's take a look at how this works as actually the drag and drop, and then I'll go into the actual template itself. All right, I'd like to do first, in this particular case, a face mill operation. Sorry, not a face, a facing operation on this face over here. I'm just going to take this template that I have over here, drag it to that face. That shouldn't have happened. Ah, yes, I know why. Because I already did it once before and I forgot to delete it. Okay, so let me just delete these operations. Wasn't paying attention. My fault. Okay, let me do that again. Drag it to that face. And you can see that that operation was created. Let's run a quick simulation just for that. And you can see that it is being now taken off. That face was exactly according to the way it was saved in the template itself. Okay. Now, the next thing I'd like to do is say I want to turn the outside from here all the way down to this part over here. So I have some more templates down over here. In this particular case, I want to do these are templates that I created. I want to do one that I called outside turn on the solid with finish to include my finish cut. Now, since I want to go from here till here, when I drag my template on my keyboard, sorry, that's the wrong template. That's the one I want to drag. As I'm dragging it on my keyboard, I'm going to hold Control. I'm going to click over here and then click over here. When I let go of my keyboard, of my control, you can see that it did exactly what I asked it to do. Okay? Let me just go for a moment into the operation and show you exactly what is important to notice also when you're creating this kind of a template. Okay? What are we actually saving in the template? In the template, we're saving the fact that I'm using a solid. Okay? Now, also, let me show you the inside of the actual geometry itself. In this particular case, I was working counterclockwise. Okay? What else was important? Edit geometry, my modified geometry is also saved. Whatever I created in my modified geometry is saved inside the drag and drop template. So you can be sure that you'll know that the kind of extensions you want over here is exactly what you'll get when you use this particular template because you created it. Okay? And when I save the template, one other thing must be taken into note. We included over here, remember I told you about the direction of the geometry? Over here, when you save the template, include geometry direction. Okay? That is important to check that off if you want to make sure that you keep the direction you want. If you do not click on it, then when you use the drag and drop, it'll ask you when you release it which direction you want to go in. Okay. But this is why it already went automatically in the proper direction. Now let's continue. I'd like to do this area over here, this slot, this groove over here. So I'm going to drag the groove. I'm going to hold my control button over here. Now I have a 3D connection mouse over here, so it's easily for me to turn it over there. And I'm going to click over here. I probably did something wrong over there. My hand slipped, my mistake. Okay. There we go. I'm going to get rid of this operation that I have over here. I'm going to redo it. Okay. Again, let me go to the groove, drag it to this face, hold my control, turn my part a little, click on this face, let go of my control. I'm having a little bit of a problem over here. I'll figure that out a little later. I know why. I accidentally copied the part over here. That's not my part. Let me delete that. Okay, silly me. Okay, so let me go back into this over here again. Hold my control. Let me see, did I click on the face? No, I didn't click on the face. From here to here. Let go. And there you go. Again, I messed something up over here. I think I did it twice. I forgot to delete what I had over here. I like to do this to the end, so bear with me. And this time I will get it right. Okay. One of those days when it rains or pours. Okay, so drag it. Hold my control over there. Turn my part around. Click. I didn't catch it for some reason. Okay, one more time and that's it. Delete. Drag it. Okay, here we go. This time I got it correct. And let go. And there we have our toolpath. Actually is facing us at this moment. Right over there as well. Let's take a look at the simulator. You know what? Let me do one more. Let me do also the thread. I'm going to just drag the thread to this diameter over here. Let me zoom in a little over here. This one over here. And I have my thread here as well. Let me run now the simulation on everything over here. Okay, run it from the beginning to the end. Face, slot, outside, and the thread. So everything here was done with drag and drop. Okay. Now let's get to our last topic. And in order for me to do this correctly, I have to close my program here. And you'll bear with me for a moment because right now I worked on the full version of SolidCAM. But I'm going to go now into what we call SolidCAM ShopFloor Editor, what Emil had mentioned in the beginning. Now, the SolidCAM ShopFloor Editor is a specific version of SolidCAM that it's actually really a fantastic tool for making minor changes in the operations that can be done by the machinist himself. So for one, he doesn't have to always bother the programmer every single time he feels the change. Let's say he's listening to the machine, there's a little bit too much vibration, he has enough experience, he just wants to make some changes in the feed rates and the spin rates, and he can do that all by himself. Notice this program is just for making the edits, the small minor edits that he needs. Or let's say person is working a night shift, okay? And it happens very often, not too often, I hope, but sometimes, tools do wear down and the machinist has to change the tool. And he finds a new tool that he has, but this particular tool is not exactly the same as what he has inside the machine. So he has to make minor changes to that as well. So in order for him to do that, he's not going to call the programmer in the middle of the night to come down and make the changes. He can use the SolidCAM ShopFloor Editor to make those minor changes. And I'm going to show you in a moment how this works. But in order for me to do that, I have to change my own personal license, because the license that I have is for the full version. So let me just change that. So just give me a moment while I change my license. Okay, let me see. Change. Let's see. I might as well show you what I'm doing while I'm doing it. So in case anyone wants to know how to do this, if you have license issues, let me just go into where my SolidCAM is. And let's go into software licenses. And I'm doing a transfer license. I'm going to save my old license to this computer, so I can always go back to it. I'm saving it to a particular area over here. I already have it. Now to open up my other license, when I get a new license, which is what you should always know also as well, if you ever get a new license, is that go back to the same area, software license, and if I go back to transfer license, I can activate the license transfer. I'll go over here. I'll go into my, here we go. I saved it over here, my ShopFloor Editor license. Okay. Now, as Emil had mentioned before, ShopFloor Editor works both as a standalone and within SolidWorks itself. If on the floor you don't need SolidWorks, all you need is just the editor, no problem. Let's take a look how this works. I already have a link to it over here. And it opens up SolidCAM as a standalone. Okay. You'll note that I can only open parts. Okay, let's go into, let me see. Go into a different part that I have over here. Let me close this over here. And let's see, open. We'll go into our getting started parts. And let's go, let's go to this one over here. Okay, you can see that we have, if I were to try to create an operation, say that, you get a notification telling me that you need a full license to create an operation. Obviously, without SolidCAM here, SolidWorks itself, you can't create one anyway. But if this was integrated, you would not be able to create an operation. Okay, you can't copy or paste it either as well. What you can do, I can go into my toolkit, and let's say, as I mentioned before, I have an end mill, this particular end mill over here, this 16mm end mill. And in the middle of the night, I have to change it. And when I come back to change it, I find that the only end mill I have, instead of my cutting length being 19mm, the one I have is only 4mm. That's all I have. I'm not going to stop the work because of that. So I make the change over here. Now save and exit. It shows me also what operations it affects. You can see it affects these operations over here. Let me go into this particular operation. Okay. Now, like I said, there are other changes. I can do edits over here. For example, if I go into my levels, my maximum step down is 6mm. Well, now that I have the cutting edge is only 4mm long, this will not be good for me. So I'm going to change this to say maximum step down to 3mm. Okay. Now, If I want, just for your information also again, if I need to change any of the data over here, as far as my feed rate, spin rate, I can do that as well. If I want to change my feed rate to 1,000 instead of what it was before, no problem. All I have to do is now save and calculate. Okay? And let me just calculate all. By the way, you'll note also, if needed, I can also create Gcode over here. Could I have to create a new Gcode in this particular case? But let's take a look at the simulation for this pocket now. Okay? Run my simulator. And you'll see that it goes down with several steps now this time. Okay. Now, this doesn't only take this type of simulation. Also, by the way, I can run machine simulation here as well. Let me run a different part. Let me go into here. Let me run this HSM part over here. Yeah, I'll take that one. You can see again, I have all of these over here. I can make changes. If I want, I can run my simulation. This time, I want to run my machine simulation. I need to create an STL file. Okay. So you know what? I'm going to go into, right now I can't do it in this particular part. Let me go into a different part. I know what the problem is, but I'm going to open up the different part. Excuse me. You know, instead of opening the port, what I'm going to do, we said ShopFloor Editor runs as standalone, but it also runs inside SolidWorks itself. So let me actually open up SolidWorks, and we'll see how it runs over there. Okay, let's see what's going on. Okay, meanwhile, I'm asking some questions I see over here. There's a question over here. Can thread function also work in turning operations rough patterns? Yes, the threading also has the patterns inside our turning operations. We've had it there actually for several years as well. Okay, thank you for telling me that machinist was spelled wrong. Okay, even I make mistakes. Okay, so let me open up now the part. I'll go to that exact same part that I just had. Now, you may think that inside SolidWorks, when I'm working inside SolidWorks, that I can create an operation because I have a or anything like that. Well, let's see what happens if I try that. Again, operation, add milling operation. Let's do profile operation, for example. You see again over here as well, you'll get the issue that you need a full license. Okay. Now, let me run my simulation. Now you can see my solid verify. I do have solid verify, of course. You can see that over here as well. So you can run all my different types of simulation over here. Okay. Let me just see my target for a moment. You see I have my target here. Let me just click on show to see if I can see my target. I can see everything very well. And again, even though I'm an editor, I should be able to run my machine simulation as well. Let me open up my machine simulation. There we go. Now, the reason, by the way, it didn't open up in the standalone is because this, for some reason, this part was not, the STL was not created beforehand, but now it was, so it will be able to open up in the standalone as well. Okay, in any case, you can see I'm in the edited version. Let me just turn the part around a little. And you can see that I can run my simulation here without any issues, even though I'm in the edit-only version, the ShopFloor Editor. Now, what we mentioned before also is we have ShopFloor Simulator. What is the difference between ShopFloor Editor and ShopFloor Simulator? ShopFloor Simulator is the exact same thing as a ShopFloor Editor, except that all you can do over here is just run the simulation and just also reprint the Gcode. That's all. That's the basic difference between the two. Many times people want that for their machinist. So before they actually start working on the part on the machine, that they can actually see what is going on, what they're expected to see on the machine itself. When they run their simulation, they can see exactly what's going on the machine before they actually see it on the machine itself, which helps them out a lot. Okay, I'm going to stop now. I just see I have a few questions over here. The ShopFloor Editor changes made on the floor so that when it is reopened in full SolidCAM, programmer knows the changes were made. Yes, it does. It opens up, when you open it up in a full version, those changes stay there. Unless, of course, you gave him a copy and not the original. Okay? How many times can you transfer SolidCAM licenses? As long as it's your same computer, not a problem. If you transfer, you can't really transfer that easily from one to the other. But I believe, look, you can go back and forth. I've changed my license back and forth over here on my particular computer over here at least 10 times in the last week, just practicing. So you can do it pretty often. I don't think there's a limit on that. Okay. Let's see what else we have here. Now, by the way, this has been recorded. Someone asked me if this has been recorded. Yes, this has been recorded and will be available later on to everybody to view. And also all of these other questions that may come in. Any questions that may come in, I will be able to see that also later on as well. You can always write questions in later on. Now, there's a question. One question is there anything that indicates to the programmer that a change was made by the ShopFloor editor? The answer is no. Okay. At this point, right now, you're the person who is actually the machinist should always be in contact or leave a note or something like that to the programmer that a change was made. At this point, there is no way unless he actually looks at the program. Okay. Is ShopFloor Editor available on a dongle? Yes, it is. It's just like any other license. It can be put onto a dongle or into a software key. I prefer working in a software key, but everyone has their reasons why they want their particular license in different ways. But yes, it definitely works on a dongle itself. Can you add a new tool in the ShopFloor Editor? Yes, you can. Okay, that can be done. Okay. Again, thank you everyone for joining the webinar. I hope you got plenty of information that I was able to give out there. I hope it was worthwhile. I'm sure it was. And as I said, this has been recorded and will be available to everybody later on. Take care, everyone, and have a great week. Bye-bye.